Hi, I wanted to make a video addressing these complex fractions that contain negative exponents. So I'm sure many of you know that a to the negative 1 is just 1 over a, but that may not help us when we get to something like this monstrosity, where we have a bunch of negative exponents and they're mixed with terms and they're in a fraction, and it just gets really intimidating to even know where to start. So the first thing I want to do is emphasize which exponents are associated with which terms and which part of terms. So typically the exponent only affects the term or the piece of the term that it's directly touching. So this negative 1 would be associated with this a and not with the 4. But since this negative 1 is outside of the parentheses, it affects everyone inside the parentheses. So this negative 1 would be associated with both the 4 and the a. Here we again have just a negative 1 and it's only touching an a. And here we have a negative 2, but it's only touching the a, so it does not affect the 4. So let's go ahead and rewrite this using our exponent rule and putting everything over a so that we can get rid of all the negative exponents and make this fraction a lot easier to read. Okay. So this would be 4 times 1 over a plus 1 over 4a all over 1 over a plus 4 times 1 over a squared. Now we've got a mix of fractions and 4s. Some are in the denominator, some are just sitting next to a fraction. So let's try and rewrite this one more time to take some of that out and resimplify. So this 4 times 1 over a, that would just give me 4a because I can just mix it in. And the same here. So using that, I would have 4 over a plus 1 over 4a all over 1 over a plus 4 over a squared. From here, it may be really tempting to say, well, this 4 and this 4 can go. That doesn't work, however, because we have addition in the middle and not multiplication. You can only cancel out pieces of a fraction across multiplication. So there's nothing we can do to reduce this. What we can do is either choose an LCD for the entire fraction, so find an LCD for all 4 of our denominators, or, usually the more popular one, is to turn both the numerator and the denominator into a single fraction from these double fractions that we have right now. So that one's usually more popular for my students, so that's the method I'm going to show here. So that means in the numerator I need to get one single denominator that would work for both fractions. So the LCD for just the numerator, that would be, let's see, 4a. So I have a 4a in this fraction and just an a in this fraction. So combining with variables, I know that I can just keep the 4 and I only need one a. So the LCD for the denominator, however, this fraction has 2 a's and this one only has 1. So the lowest common denominator still has to have 2 a's since this one has 2. So building up the fraction for the top, this first fraction in the denominator is missing a 4. And the second fraction is not missing anything. So I need to multiply this guy by 4 over 4. 4 times 4 over 4 times a. plus 1 over 4a. All over, in the denominator, this fraction is missing an a. But this one already has the two a's that I wanted. So all I need to do is multiply this guy by a over a. So a times 1 over a times a plus 1 over a squared. So I'm going to go up and over and simplify. No, looks like I'm going to need a new slide. So I'm going to take this and move it on to the next slide. Okay, so I've moved this on to the next slide, so I have lots more room to work with it. Now I need to actually do the multiplication in the numerator. I get 16 over 4a plus 1 over 4a, all over a over a squared plus 1 over a squared. Now I need to combine the numerators into 17 over 4a plus, over a plus 1 over a squared. Now I'm going to do that, keep, change, flip. I keep the numerator, I change the division to a multiplication, and I flip the denominator over. Keep, change, flip. So do this in a new color because this is where we're doing the complex fraction part of the problem. So keep the numerator, change division to multiplication, and flip the denominator. So the numerator stayed the same, I have multiplication, and the denominator is now reversed. Now, when I have only multiplication between these, I can cancel this a squared with a single a down here. Unfortunately, there's nothing that can go with this 17, and there's nothing you can simplify with this a plus 1. So the fully simplified form of the solution is 17a over 4 times a plus 1. And yes, you can distribute this in, but it doesn't actually simplify the fraction any further, so it's not necessary. This would be our solution. Alright, I hope that helps with complex fractions that include negative exponents.